We humans are obsessed with time. We measure it constantly. We celebrate its passing. We even dream of controlling it, of traveling through time. Imagine journeying to the past, witnessing historical events, or speeding into the future. Time travel has captivated our imaginations for centuries. But is it just a fantasy, or could it be within the realm of scientific possibility? In the realm of science, time travel is a complex and intriguing concept. It involves understanding the very fabric of the universe, space and time. While we haven't built a working time machine yet, the laws of physics as we currently understand them don't entirely rule it out. Join me as we embark on a journey through the cosmos of physics to explore the tantalizing possibility of time travel. The idea of time travel is older than you might think. Ancient myths and stories often feature characters jumping through time. Think of the Greek god Kronos, who controlled time, or the Hindu god Vishnu, who could travel between different epochs. These tales reflect humanity's age-old desire to transcend the limitations of time. But it wasn't just mythology. Early scientists also pondered the nature of time. In the 17th century, Isaac Newton viewed time as absolute and unchanging, flowing at the same rate everywhere in the universe. This Newtonian concept of time, like a river flowing endlessly, dominated scientific thought for centuries. However, this seemingly simple view would be challenged in the 20th century by a revolutionary thinker, Albert Einstein. Albert Einstein, a name synonymous with genius, turned our understanding of time upside down. His theory of special relativity, published in 1905, proposed that time is not absolute but relative. What does this mean? It means that time can pass at different rates depending on your relative motion. Imagine this. The faster you travel through space, the slower time passes for you relative to someone who is stationary. This mind-bending concept, known as time dilation, has been experimentally verified. Atomic clocks flown at high speeds in aircraft tick slightly slower than identical clocks on the ground. This might sound like science fiction, but it's scientific fact. Einstein didn't stop there. His theory of general relativity, published in 1915, proposed an even more radical idea. Gravity warps spacetime. Imagine a bowling ball placed on a trampoline, causing it to sag. That's similar to how massive objects warp the fabric of spacetime. This warping, according to Einstein, is what we experience as gravity. Now, what does this have to do with time travel? Well, some physicists believe that extreme warping of spacetime could create shortcuts, or tunnels, connecting distant points in space and time. These theoretical shortcuts are called wormholes. While we haven't observed wormholes directly, their existence is consistent with Einstein's equations. If wormholes exist and are traversable, they might just be the time machines of our dreams, allowing us to journey through the cosmos across vast distances and perhaps even through time itself.